Okay, so we use standard form when we're looking at very large or very small numbers. It's a special way of writing numbers to avoid having to write a lot of zeros at the start or end of a number. So numbers written in standard form are written in a special way. So these are three examples. 2.35 times 10 to the 6. 6.4 times 10 to the negative 3. 1.97 times 10 to the negative 8. These are all in standard form. Note, there's something special here. This value here, in each case, is between 1 and 10. In other words, there's just one digit before the decimal point. They all have multiplied by 10 to a power. And then our power is different depending on our number. We'll talk about that more in a minute. But that's the important thing. They're always, the first part is between 1 and 10, so they have one digit before the decimal point, and then times 10 to a power. Now, the power of 10 can be positive or negative, depending if the number being represented is a larger number or a smaller number. If the number is a big number, then the power is going to be positive. So 5.8 multiplied by 10 to the 4 is a bigger number. If the number is a small number, the power is going to be negative. Okay, let's look at some more examples. So changing from ordinary form to standard form. So ordinary form is how we think of a number. So if you see ordinary form, it just means the number as we usually see it. So here's a big number. 459 0 0 0 0 0 0 0. So we've got 1, 2, 3, 4, 5, 6 zeros, 7 zeros. So that's 4,590 million. Okay, it's a massive number. We don't have to write all those zeros, so we're going to try and write it in a slightly different way. Now, the important thing is we must not change the value of the number. It has to still represent this same amount. But we've already said that a standard form is a number between 1 and 10 at the beginning. So how can we change this number so that it's a number between 1 and 10 at the beginning? Well, all we have to do is move our decimal point so that it is just after the first digit. So, for our case, it would be 4.59. That was pretty straightforward. You're just placing the decimal point immediately after the first digit. Then we write times 10 next to it, because we know it's in standard form. And our next step is we need to decide what the power should be. So this is where we're deciding what power we should have. Now, the decimal point had started at the end of the number. The power is going to be determined. The power is going to be determined by the number of places the decimal point has moved. So the power will be determined by the number of places the decimal point has moved. So if we go back up to here, our decimal point started off here. We know it finished here. How many places did it move? 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So a 9 would go up here. So the number 4,590 million in standard form is 4.59 times 10 to the 9. Okay, let's look at this number. This number is a small number. We can tell it's a small number because it's 0.000. Okay, so straight away we know that we're going to be looking at a negative power. Principle is the same. First of all, we move our decimal point so that it's after the first digit. So that in this case would be between the 3 and the 8. So we write 3.8. We write times 10 because we know it's going to be in standard form. So now all we need to do is count the number of places that our decimal points moved. So it started off here, ends here. So 1, 2, 3, 5, 6, 7, 8. moved 8 places. Because it's a small number, we know it's going to be a negative power, so it would be negative 8. Here's some examples here. Pause the video, have a go at these, and check that you're right afterwards. The last one I should point out is a sneaky one. Be careful with that. Okay, so these are the answers. And as I said, look, this last one was sneaky because it's times 10 to the 0. The decimal point didn't move anywhere, so therefore it was a power of 0. But to be in standard form, it needs to have this times 10. So now let's look at converting standard form to ordinary form. So in these cases, we're going to be going the opposite. We're doing the opposite operation. So we're going to start off with something that looks like this, and we're going to end up in ordinary form. So we know that this having a positive power means that the number is going to be essentially bigger than 1. Okay, so it's going to be a big number. So when we're multiplying by 10 to a power, the power is going to tell us how many places to move our decimal point. So we know it's going to be moving to the right, so we're going to write 3.41, and we're going to write some zeros over here to the right because we're moving our decimal point that way. We then jump 6 places. 1, 2, 3, 4, 5, 6. I'm going to chop off my number there. So our final answer is 3, 4, 1. 1, 2, 3, 4. Okay, so we've just copied our number. We don't need to write the decimal point at the end. So it's just 3, 4, 1, 0, 0, 0, 0. Okay, the next one. Oh, let's make this a negative 6. So 2.3 times 10 to the negative 6. So this time, because it's a negative power, we know we're going to be moving our decimal point left. So we're going to write 2.3, and we're going to put some zeros this time to the left. So we're moving 6 places to the left. 1, 2, 3, 4, 5, 6. So this is 0.00000023. Now here I would put the 0 in front of the decimal point, and we do need the decimal point because it's a small number. Okay? And as before, pause the video and have a go at these questions and check them afterwards. Okay, so if you want to check your answers. Now, something I did point out in class, it's not essential to remember this, but if you're trying to convert a number with a negative power, note our negative power is negative 3. You will always have 1 fewer 0 than you do the power. So because this is the power negative 3, we had 2 zeros before this number 2. Let's look at this as another example. We have to the negative 5. So that means that we would have 4 zeros before our number 3, 2, 1. Okay, it's just something that may help you. A little tip for positive powers. Here we can see we've got 1 digit after the decimal point. Our power is 4. Therefore, we're going to have just 3 zeros at the end because our decimal point had to jump over 1 place, and then we could add some zeros. This one, we have 2 digits after the decimal point, and we have a power of 7, which means that we're only going to have 5 zeros at the end because our decimal point had to jump 2 places, and then we could add zeros. So sometimes it's a good thing for us to be able to check that.